Hi everyone, welcome to WeeklyWed. This is your host Yash from Bangalore, India. Before I introduce WeeklyWed and I introduce myself, I want to say that this meeting is recorded. It's a podcast and it's recorded. If you do not want to be seen, please turn off your video. And if you do not want to be heard, then please put the question in the chat so that I can field it. Welcome everyone. Welcome to WeeklyWed. WeeklyWed is our go-to place for AI, AV, IoT. It's from Business School of AI. And here we have students of Sudha coming from Stanford, Barcelona, and other European schools and LinkedIn Learning. Yes, Sudha is having a new course on LinkedIn Learning now, which will be out in some time. And WeeklyWed is the community where we have continual learning. We have international speakers here who come every Wednesday and share their knowledge with us. It could be research knowledge, theoretical knowledge, or from the industry perspective. And today we have a very special speaker, Supriya Raman, with us. I'm your host, Yash. I'm an AI researcher and I've been hosting WeeklyWed for quite some time now. And Supriya comes with 18 plus years of experience. She is a senior vice president, data engineering at JP Morgan Chase. In her current role, she is responsible for defining, leading, evangelizing analytic solutions, leveraging data science offerings. She is directing end-to-end model development and development lifecycle, accomplishing mission-critical, user-centric deliveries using Scrum methodology. The key skills of Supriya are natural language processing and generative AI. She's also involved very much in career mentoring, and that's how I came to know Supriya. Upskilling and coaching students from reputed universities and working professionals. I am Google Women, Supriya is Google Women Techmaker Ambassador and part of IEEE. She delivers thought leadership and innovation in process, technique, and implementation. Welcome, Supriya, and the floor is yours for you to share your learnings with us about enterprise, about how you have been using cloud, how you have been using GenAI, and we're all ears for that.
Thank you. Thank you so much, Yasha. Thank you for having me at this platform. And as always, you had been very kind of talking to me at that length. Make me feel very humble. Thank you for having me here. And hello, everyone. Today's topic is around generative AI, and I'll start sharing my screen so that I hope my screen is visible, right, Yasha?
Yes, I can see your screen. And for everybody, please chat where you're coming from, what's your name, and let's have an engaging discussion with Supriya.
So, at a high level, if I talk about today's agenda, I will be talking mainly about starting with how Gen AI and the complex LLM model came into picture. And before we pitch into that, there are a few things which we will talk about. We will understand text at a high level. We will talk about a transformer architecture. Basically, if you take any of the LLM, they are encoder decoder models and mainly based on transformer architecture. So, what is this transformer architecture at a high level? And then we will explore the generative AI lifecycle. Basically, if you are developing any projects through generative AI, what does a lifecycle looks like at a high level? And then because we are using these large language models, right, so there are different flavors of how you can be utilizing it. So you can do a prompting, you can do a RAG, fine tuning, or RLHF, and we will explore what does these terms mean at a high level. And then we will quickly switch gear and we will figure out, of course, there had been different architecture which has been developed using LLM, but we will actually figure out a very generic architecture which we have, and then we will discuss through some of the common challenges which we have in developing such GenAI applications. With that, let's first start with understanding the text. And when we say understanding text, it is mainly, if on the right side of the screen, if you see, it always start from text or speech or phonics, and then it end up being syntax, semantics, discourse, and other things. So actually, if you talk about the breadth of text, it is very, very complex in order to understand through. And at a high level, if we really want to understand text, we can divide it into three main categories. So to start with, we have lexical processing. The best example of lexical processing is identifying a spam ham message, right? In this process, what we do, we generally divide the whole text into small tokens or small words, and then we just want to understand the meaning of those particular words. So taking the example of spam and ham, suppose you have to identify whether a particular mail is spam or ham, you can quickly make it out only by the words which has been used in email, and that is best example. And then we have a lot of other examples where you can just tokenize, and then understanding the tokens separately make a lot of sense in analyzing that problem. But text is not that simple, and therefore the next level to us is syntactic processing. When we say syntactic processing, it is related to syntax of the language, and that's why it is directly related to how the language has been written and the part of speech. So in this case, we actually talk about what are the different part of speech to which the word belongs to, whether it is a noun or a pronoun or adjective or adverb or what it is. Similarly, whether a particular word is an object or subject or predicate and so on. So we generally try to put the part of speech together, and then we try to understand the meaning of the whole sentence all together, and that is syntactic processing. But the most complex part of it is about the semantic processing. And when we say semantic processing, it is basically understanding the text beyond what the text is written there. So suppose, just to give an example, I tell that the cat is walking. And if I say cat is walking, we all have an image of cat which get built in our mind as a human. And although I have not described what a cat looks like, right, we can imagine that it is a small animal with two eyes or tail and so on. So that semantics is basically our inbuilt knowledge which has been built inside it. And those semantic, this is what exactly semantic is, where you have to supplement the text along with the other general knowledge or domain expertise in some cases, specifically in the case of healthcare or even in terms of banking. We have a lot of domain specific terminologies, and we have to supplement the text processing along with the domain knowledge. And the discourse context is obviously where the similar word can have different meaning in different senses. Like to give example, suppose you take the word bank, then bank can be a financial institution and bank can also be a river bank. So same word can mean different in different scenarios, and all of these together, the general knowledge, the domain knowledge, and the discourse context has to be supplemented together in order to make us understand the semantics of the processing. With that talking, before we actually step into Gen AI and LLM era, I'll talk about the traditional NLP which we were doing before we had LLM. And it always started with tokenizing, where you're breaking up the huge document either in form of sentences or small words or even in small tokens. And then you try to understand, you first tokenize it, then you do a lot of pre-processing step, which is not now relevant in terms of LLM because the models itself take care of those. But in the pre-processing step, we used to do steps like removing the stop words, because if you see the grammar or if you see any of the language, right, the bigger context of the language contain a lot of joining words. Like you will have a lot of prepositions or conjunctions which might not make really sense in terms of the semantics or the context of the text. So those stop words has to be removed. And stemming and lemmatization is basically because the data is too huge. You really want to compress the bag of word, and in order to do that, you try to reduce the word to its base form. So those are two techniques we used to do in the pre-processing steps. And then finally, when we have done this pre-processing, we actually used to step into bag of word, creating a bag of word. So if I talk at a very high level, what is bag of word? Bag of word is basically, you have several documents in this case, and if you take all this document and if you remove all the stop words and you take the frequency, this is the simplest way of creating a bag of word, where you take each document and you count through the different frequency of the words which you have, and you mark it as 1 and 0 depending on whether it is present in that document or not. But this is the simplest meaning of bag of word. And of course there are different methods by which we use to create the bag of word, like one hot encoding, count vectorizer, TF-IDF, and so on. And finally, we use to create the word embedding. So this is traditional NLP which we used to follow before we had LLM or GenAI. Also, talking a bit about the context and semantics. If you see the first sentence here, and this is a very good example of talking about how the semantics can go wrong. Generally, when we talk something in a particular language, it might not have the literal meaning of what the sentence actually mean, and there is a lot of background knowledge which is required in order there is a lot of background knowledge which is required in order to understand that, and that is what exactly is semantics. Also, the context. When I talk about the context, then if you are trying to, all the LLM basically is based on the fact that you try to generate the next token, right? So if you see the first example here which we have, it is a glass of orange water, and I am very sure that 90-95% of us will say it is orange juice. But how does this word juice comes into picture? Is it not related to the word orange before it? Or might be it is more related to the word glass before it. Because if I will say she was wearing an orange, then it might have been a dress, right? So the next token prediction in case of any of the applications which you try to solve using LLM, depends on the context, and of course the context are the surrounding words which can be pre or post of it. But in this case, the context is too small, and we are just taking the context which is one or two one or two words before, right? But you can see in the last example which we have here, and this example says that I met this French girl Emily in a conference last year. We fell in love instantly. My parents are conservative, so I planned and organized a blind date with my parents. They loved her. My mother hugged me right after Emily left. Even my dad gave me that rare wink. I'm so excited. All that is left is to convince Emily's parent, and here I am booking my ticket too. Now, where is this person trying to fly? And of course, because she is a French girl, he might be trying to fly to France. But in this case, because we can, as a human, we can understand that the next word prediction. But if you see, if you have to really process it using a model, the context is not even words apart, but it is sentence apart. And that's why sometimes predicting the next word is too complex. Also, while we are predicting, we are talking about the complexity of the context and the semantics. The important thing to note here is also, if you have a predictive analytics and you have to predict through, suppose you have to predict through what impact the global oil prices, right? Then you can count, demand and supply and other things. You have a data and you can predict onto it. But if I ask you a question, that what are the factors which you think make your son or daughter resemble you? In that case, we all know that there is resemblance, but there is no specific answer of how he or she resemble us, right? So that's why, in order to understand this context and semantics, and because we understand that this cannot be expressed in something as clear as a predictive analytics, right? Therefore, we do have neural network and reinforcement learning. When I talk about neural network, you have auto feature extraction. Therefore, in this example, if you see, what it is trying to do is, you have a picture, and then depending on the network which you have kept through, the idea is to predict whether it is a dog or a bird and a cat. But how will you predict that, right? Can you do feature engineering, or can you say that this is the color because of which it looks a bird, or this is a organ or the part of the picture because of which it is bird? We cannot, there is no finite number of features which we can call out in a particular picture, and that's why neural network plays a vital role, because in that case, feature extraction which happens in the multiple hidden neural networks is auto done. It's automatically happens. Also, talking about the reinforcement learning, which will be a crucial part, and we will see how reinforcement learning is a crucial part of LLM, is where, best example of talking about reinforcement learning is in a robocar. You will always have an agent, and there is no finite number of actions which you can give it to this agent in order to figure out that yes, these are the patterns which you learn and then you learn driving. It cannot be. So how does this agent actually learn the process of driving? Of course, they take a lot of actions, and that action has been taken into the environment, and depending on what action the agent takes, they will always have rewards. Rewards can be positive or negative, and depending on what reward they have seek through, they go to the next state, right? So robocar is one of the example, and then we have reinforcement learning now in healthcare, where we plan to do auto surgery and many other things. So we are trying to implement reinforcement learning in many of the fields. But we will search out that how it, in upcoming slide we will see how it actually is embedded in LLM. With that, before we go to generative AI, right, we can see a roadmap of how the journey used to look before the generative AI come into picture. And some of the important fact which I would like to highlight here is, if you see machine intelligence, it is, we think that AI and ML is too new technology, but you can see that machine intelligence is something Alan Turing introduced in 1950. Also, the first chatbot which we had was called Eliza, and it was there in 1965. So some of the very interesting fact, and of course, this all, you know, machine learning or Gen AI or AI has been handed over to us only after 2017 and 18, where university and schools came up with the courses, and it becomes very vital. It became so open and so easy to learn and understand, because the courses and the understanding part had been made very easy into the market. So with that, we come to the actual topic about rise of LLM, right? And when we talk about the rise of LLM, of course, this is one of the era where, when you talk about LLM, you are no more just trying to predict something, but you are saying that using this large language. And first of all, what is LLM? LLM are pre-trained models. They are huge models which has been pre-trained on huge amount of data, which took a lot of time to be pre-trained. But the benefit of training such model is that these models can now perform many of the generic tasks together. Like they can do summarization, they can do essay writing, they can do classification, and many of the generic tasks. So if you really want to do those generic tasks, or even if you try to optimize such of the generic tasks, you can use this LLM as is. So you use this LLM, you download this LLM, and then you can reutilize those. So the benefit is, the pre-training of these LLMs is very very computationally heavy, and also very time consuming, and it is an expensive effort. But when you are reutilizing it, it is too quick and too easy to do that. And also, it saves a lot of time and effort. And also, if you see the journey of it, of course, we started understanding about LLM only when ChatGPT came into picture in 2022. But if you see the journey, and this is only the journey of OpenAI LLM models, it starts somewhere from GAN models, which we had in 2014. And of course, GAN is not LLM, purely LLM, but this is surely a base of how the LLM started coming into picture. In 2017, we had a picture, we have a paper, Google paper, which came into picture, which is called "Attention is All You Need." And that paper actually introduced the base of the transformer architecture, encoder decoder architecture. And soon after, we came up with GPT 1, 2, 3. Now we are at GPT 4, and we have 4.0 now. 4.0 is basically multimodal architecture, where multiple form of data can be trained and processed in a single large language model. So you don't need to have different models in order to process images or sounds or text. You can use a single model and you can process all of those. So we talked about attention is all you need, and of course this is the paper. And if you see, this is the diagram which has been taken from the paper itself. This is exactly the diagram which has been kept into the paper of attention is all you need, which came in 2017. And basically, we will understand this picture, but at a very high level, it composes of two things. It composes of an encoder, and then it composes of a decoder. And the first problem which they were trying to solve using this model was language translation. So we'll see what exactly this paper talks about in encoder and decoder in the upcoming slide. Now, a few of the questions before we actually go into the language, transformer architecture. First thing is, what is generative AI? And of course, as we talked about, it is no more predicting based on today or past data or historic data, but now you're generating, you're creating a new context altogether, which is a creative writing. And also, it is not something, it is, fetching it as is, but it is creating the new content altogether. And the content which is being created can be anything. It can be text, audio, video, or sound, or anything. When we say LLM, we understand that it is huge model which has been pre-trained on large amount of data, and then we can use, and it can perform a wide range of tasks, right? So now the question comes: are all LLMs used for generative AI? So the answer is no. They can be used for, of course, the generation, but there are models which are also used for NLU, which is natural language understanding, and we have sentiment analysis, classification kind of problems also, which we are solving using LLM. Also, there are different type of models. At a high level, if we divide it, there are transformer models, and when you, as soon as you say transformer, it is related to text and it is based on Google 2017 attention is all you need paper. Most of the models are based on that model actually as a base. And when you say diffusion model, diffusion models are those which actually deals with your images and videos. So talking about,
we will have a short discussion now.
yeah,
We
sure.
will take questions,
Yeah.
and we will address the questions now.
Yeah.
So Sudha has a question here. Is it the traditional reinforcement learning which is used in LLM, or is it reward state system like the new reinforcement learning that's used in LLMs?
Oh, that's a great question. And actually, I have a slide for it. We are using RLHF, which is reinforcement learning based on human feedback, and how human feedback is being used in order, along with the reinforcement learning, basically in order for evaluation and fine tuning those models are something which I will talk about. And I have a further slide on to that. So I'll keep that question on a little hold. Yasha.
Yes. Uh, any other questions anybody has, or we are good to go to the next segment?
I just wanted to add one thing we had covered to our speaker. We had actually covered what is LLM, foundation of LLM, and the concepts in about 4 webinars earlier here. So I'm guessing that people should have this concept of transformer model and LLM. So I'm eager to see the examples, like the challenges in actually making the LLM understand the text and how it is, real practical example from industry. Maybe you'll get to it. I'm just eager for that.
Surely we have slides for that, and might be I'll skip some of the slides. It makes sense. If might be I'll skip the architecture altogether and I'll go to the
Yeah, people are familiar with that. And if somebody is new here and they don't have the foundation concept, they can go back to our archives, but the concept of how LLM works and the various different models and parameters and transformer model and even like the different way of segmenting, structuring so that you can create different LLM types like Q&A or machine translation and all that stuff we've covered. Like sequence to sequence. Think of it like people know till sequence to sequence. Yes.
Great.
Yeah.
I'll skip that. Thank you
Thank
for
you so much. But I still loved it. It's the fastest refresher, but beautifully done. So I appreciate that. Thank you so much.
Thank you. Okay, so with that, let's talk about some of the use cases. And of course, these use cases are very generic, but I'll try to put some of my use cases I'm working on, and then we will go further. So, if I talk about some of the use cases I had been working on, one of the major use case which we had was, related to model deployment. And if you talk about model deployment, of course, these use cases which are there, if you know the basic, you might have heard through it, but I'm talking about a live use case I have been working on. And this model is basically, it is about delivering the model deployment as a service. So when you say model deployment as a service, what you mean is, suppose you have to deploy a model into the production, right? And once you have deployed it, then model might go many changes, right? It might go many changes, and those changes can be data drift, it can be data source changes, it can be anything. But every time when the model will undergo change, it will be the modeler who will make the changes, and they will test it, and then they will provide you the final model again. But as a deployment people, you have to take that model again, you have to do the configuration changes, at least the configuration changes, and there can be more changes. And then you have to test it, you have to test it again in your unit testing, you have to do the integration testing and the prod parallel and the parallel. So taking a simple example, suppose in banking we have a lot of sources where a source go obsolete, source data source go obsolete, or might be the data has migrated to a new platform. In that case, suppose a particular data source has gone obsolete, and you are now trying to fill that gap into the model. So of course the model will go through the configuration changes. Now when it will go, now suppose there are 80 or 90 model who are dependent on that source, then you have to make that changes in all those 80 90 models. And at an average, even if I take 2 months, right, of deployment, then 90 cross 2 is your man hours which you need. 90 cross 2 months is your man hours which you need in order to complete that change. So what this requirement is, suppose you have several models, so whether LLM can be used at a very high level in order to generate that code which can pretend in order to tell what can be the what can be the valuable changes in different configurable items. So while we are doing it, it has two phases. First, what we did, we have taken a lot of code we had, and we had done a labeling of it. So while you're labeling, there are different type of labels. We have 7 or 8 different categories of label, but you can have data analysis, you can have hyperparameter tuning, you can have different labels. So we have taken the code snippet and then we have actually labeled it. That is one phase. And in the second phase, along with this label data, we have taken that label data along with the LLM, and then we have fed it into LLM. So it is basically text to code kind of model, where the model actually come up with the prediction of possible changes to the configurable items. At this time, if you see at a high level how the code has been generated, is too poor. It generated hardly 50-60% of the actual code, but that also is a huge saving for me, right? If out of 2 months of effort, if the LLM is able to generate that 60% of the code, then it's a huge saving for me. And this is one of the model which we are working on, and of course it is at a very initial phase, so we are trying to fine tune the model. We are playing with the prompts, and of course the prompt is going and hitting the databases also, so we are trying to some kind of hard coding into the prompt and all. So this is one of the use case which I'm working through. But at a high level, if you think of transformer models, or if you talk about LLMs, there can be multiple ways. Even if you talk about chatbot, right, the purpose of a chatbot is generally to give you answers, but depending on what type of answers you are seeking through, right, it can be, the answer can be a summary, it can be a translation, it can be essay writing, and so on. And might be I'll go to the RAG models very soon, where I'll explain it, that we how we can route it to different version. So as clearly might be, I'll skip this slide. I'll be talking about the architectures and the models, and then I'll come back to the agenda. So of course, here we will start with generative AI lifecycle. And if you talk about the life cycle of generative AI project, choice of LLM which you have to utilize is one important aspect, but we have to understand that these LLMs are actually the one who runs on GPUs or VRAMs, and therefore you need very specialized hardware, you need cloud platforms, you have a lot of model hubs which are available for you. You have frameworks now, you have LangChain and Llama Index, where you can quickly design these model end to end. And then on top of it, you have apps to design. So this is one of the picture which I took from deep learning AI, and this picture I really love because what it talks about is, if you at a high level, if you have to break the whole life cycle of a generative AI project, then you obviously start with the scope identification. And scope identification has to be very, very specific, because as I told you, right, a chatbot can be a chatbot which will be answering you the questions, but what kind of question you want to answer, whether are you summarizing, are you doing translations, are you just predicting few next tokens, that that choice of what you really want the LLM to perform has to be done, and depending on that you choose your model, the LLM model. And then, the most important part of it, how you adapt to it. And there are four ways of doing it. And of course, there are prompting. We will talk about a few of the examples of prompting. We can do RAG models, fine tuning, and then RLHF. And once you do this, adapting and aligning of your model for your specific requirement, then you obviously go to deploy and maintain your models. So this is how, if you talk about LLM model, there are four ways. First step is, of course, prompt engineering. And when I say prompt engineering, basically you're talking about what kind of query you can submit. It's an English like language. Prompt is always an English like language which we submit in order to query these LLMs. And how efficient that prompting will be, it actually decides how better the LLM will behave, right? What kind of response you will get. And we'll see some of the examples of prompting, and specifically when it is specific, as I talked to you about text to code, or if you have SQL to code, in that cases the prompt has to be very, very apt, because you are not only expecting a response, but you want a response which actually runs at the back end, right? So if it is text to SQL kind of model, then it is not only to fetch that particular SQL, but actually your SQL should run on your databases so that it can fetch you the right results. So prompt engineering plays a vital role there. The next one is about RAG, and I'll talk about different versions of RAG which I have, but at a high level, if you have more knowledge bases and you want that knowledge to be augmented along with the knowledge which LLM possesses, then you can augment it very easily using RAG models. And I will, in a very short bit, I'll talk about different flavors of RAG which I have tried through. Next is about fine tuning, and in both RAG and prompt engineering, actually, you're trying to tweak the way you interact with the LLM. You're not trying to change the basic behavior of LLM. But internally, we all understand that LLM actually works on neural network, and it has its weights and the parameters on which it is working. In fine tuning, we actually trying to tweak those weights depending on what kind of learning we have. And we have multiple examples of fine tuning models also. LoRa PEFT model is one of them, and LoRa is something which I am utilizing. And then finally, we have pre-training. So if you have huge amount of data, right, sometimes you don't want to utilize any of these existing LLM. Rather, you will say that I don't want to perform any of these generic activity which the model perform. Rather, I'll tune my own, I'll train my model from scratch. And the best example of it was Bloomberg GPT, which comes long time back when you had so many LLM model already into market. Bloomberg said, no, I want to train my model from scratch on the finance data, because they wanted to have model very specific to the finance data which they hold through. So if you have that much of computation capabilities and you are ready to bear that cost, and also you have that much of knowledge and databases, then you can go from training from scratch. So some of the example of prompting, should I do this, Yasha, or should I skip this part, directly going to the architecture?
Yeah, we have already had webinars from
Prompting.
Robert Shankar about the the prompting techniques. So we are
Okay,
good with.
so I'll quickly go to RAG. When we talk about RAG, right, the full form of RAG is retrieval augmented generation, and what it does is, say, this is the first example where you have the base LLM, and when you have the base LLM, basically you have a query or a prompt which you submitted to the LLM, and based on how your query has been submitted, it will give you a response. But when you have a RAG, you actually try to enhance your context. And in this case, if you see the second picture here, it talks about you have external memories, and that external memories can be your databases or document or table or chatbot, and then you retrieve the data from it, right? You retrieve the data from it. That retrieval of the data is the first phase. You actually retrieve it, you store that retrieved data, and then along with the prompt which the user is providing, you also supply this retrieved data to your LLM model, and then you seek a response. This is a specialized version of RAG where I have been talking about SQL to text kind of model, right? So your data, which you really want to augment and you want to retrieve through, can also be a tabular data. And if you really want to retrieve data from a table form, then you cannot directly do it, and then you have to put a LLM there, a small LLM model there itself. So in this case, if you see the third example, it says that user is saying sending up some prompt, but because you have to augment that data from the database, therefore from the database, when you fetch the data, you run a text to SQL and SQL generation first. Depending on what the SQL generation results are and the prompt which the user has supplied, both of these become an input to your LLM model, and then you fetch the response. And the last bit of the RAG, which is very interesting, is in all these cases, if you see, RAG is just providing you the response. But the best example of the RAG, which I had been talking through, and we have implemented some of the chatbot using this, is when the RAG is not only giving you the response, but depending on what type of query you are submitting, it also have to route. It has to take an effective action depending on what your query is. So in this case, if you see, the query is what is the summary to MetaGPT document, and of course it is asking for a summary. Therefore, before you hit any of the model, you actually put a router, and the router will decide whether this is a question answer, simple question answering, so it will send you to the query engine. But in this case, it find out that it is asking for a summary, therefore it is routing you to summarization, and therefore the router different. And therefore, depending on that, that's why we had many of the chatbots which we have implemented through. In each case, you might be seeking some response, but that response can be very different. You can be just doing question answering, you can be summarizing, translation, and so on. So it is better in order to put a router at the top so that the action has been taken and you actually go only through that route in order to get a very specialized answer or response in turn. Fine tuning is another example. I'll skip this also very quickly, but PEFT is what we are using, and LoRa is one example of the PEFT model. If you see, along with the base weight we have, we also try to freeze extra weights on top of it. That is what fine tuning it. And this is one of the question which actually Yasha asked me in the beginning, and this is about reinforcement learning using human feedback. So basically, if you see this first graph, it shows that the model size and then how the performance of this RLHF model is. And if you don't do any type of fine tuning, you can see the performance. If you do some bit of fine tuning, then performance obviously enhances. But if you do fine tuning using human feedback, then it actually accelerate a lot. And therefore many of the models which we have implemented, you can put RAG, you do fine tuning depending on what your requirement is. You can combine all of these. You can combine fine tuning, you can combine fine tuning with RAG, you can combine fine tuning with human feedback, and so on. But specifically talking about what human feedback or reinforcement learning is, what we try to do is we try to create a ground truth. And again, I'll of course there is an example on the slide and we can all see, but I can give you a live example of what we have done. Suppose you have a chatbot, right? And the mere purpose of your chatbot is, suppose I'm in payments technology, I built a chatbot for the payments technology, right? And the mere purpose of this chatbot is to go and read through my knowledge repository, give me a short description of my short answer to my query, and then point me to the exact document which it want me to read through. In that case, it is very similar. The UI of that chatbot, it looks very similar to the Google search. It will give you a small description on top and then the links to follow through. You click on those links and you go, but how will you really evaluate whether this link is exactly the link? Where how will you do that evaluation? So in order to do those kind of evaluation, in order to make sure these evaluations are really correct, there are many metrics which actually now has been provided for analyzing RAG models and even the LLM models. But the best way to do that is using the ground truth. And basically what we did, we have used this kind of answers which the chatbot was providing, and then we have given it a priority very similar to what this picture shows. So different business domain user, different stakeholders, they will take this answers which the chatbot provide, and they will rank it depending on how they feel that answer is apt or not. And the kind of ranking which has been provided is now again fed back into the model along with your query. So next time when you provide a query, then the input is not only the query, or input is not only your KT assistant, the knowledge repository at the back, but also this label data which are actually marked on your ground truth. So this is basically one of the example of reinforcement learning. Any questions here? Yasha, you had a question. Did this slide answer your query?
Yes. Sudha will be asking a question now.
Yes, if you have a question, it's okay. I don't want to ask all the question, but application of how they're building the chatbot here was very helpful. I do have a question, if it's okay, if I can ask.
Sure.
Yes.
Yes, thank you so much. So this is actually very, very helpful because I think we have done the concepts of LLM, RAG, and how to do this with LangChain at a theoretical level, right? So what you're saying about how there are metrics and you use them, right? Like is it like dogs precision or pages precision, or what kind of metrics, and who decides in the team? You have the data science team, and then you have the business team and several other teams in the middle, right? Who decides these metrics, and how do you actually tie that to your business case?
Okay, to example, maybe I'll go back to, I have a slide for the metrics. I'll go there. Yeah. See, basically when you're trying to evaluate your LLM model, right, there can be multiple aspects of how you want to evaluate and why you want to evaluate. One primary aspect of it is always related to cost and latency of it, and cost and latency, it depend on your LLM inference, and there are formulas. I have a separate calculation. There is a lot of formula which has been used in order to really find out what is LLM inference, how the cost has been calculated and all. So there are many metrics which we keep only to monitor the cost and latency, and this is a very crucial part because we actually want to maintain that cost because it should not be that we are your estimation, you have provided an estimation, and your project should lie in that estimation budget, right? So it is very, very important that you monitor all your costs. And of course, there are a lot of things which you can do. If you are developing it in cloud, there are a lot of metrics which the cloud platform also provide, but we have metrics developed around it. But to answer your question, right, how you decide how to evaluate, right? And there are a lot of metrics which are available, like we have ROG, and we have Blue, and so on, which work on cross entropy and other thing, and of course we measure on those. But also, if you see the first one, right, it talks about multiple metrics. It talks about answer correctness, it talks about relevancy, semantic similarity, and faithfulness. And then you have a different version of the same minstrel is one of the LLM model. And the second column here, it talks about the base model. Then it talks about fine tune the model. Then it talks about the model plus RAG. And then the last one, it talks about the fine tuning plus RAG. And this is actually the exact answer which I have worked on one of the project. And this is the data which I have collected too. And you can see that depending on, of course, there are formulas behind it, but depending on how you are fine tuning, and there is cost associated with each of it. So there is always a trade-off between whether you really want to do a fine tuning and RAG because you have a very good metrics here, but whether you really want to go through it. But if you see that even if you take a base model and do a RAG onto it, your metrics are not that efficient, but it is not that bad also, right? So always there is a trade-off between those and what you really want to utilize. Now, if you have RAG kind of model, then there are RAG triage which we use. And RAG triage actually talks about three things. It is not only your query versus response. Of course, the response has to be very close to the query, and we measure it using cosine similarity and other metrics. But there is a third aspect of it, which is called context. So context is basically what kind of context which you have utilized in order to answer my query. And therefore, when you measure any of the RAG kind of model which we have implemented, we have a triage. So you not only measure the question versus answers, you also measure what is your relevance of your answer to your context and also your question to your context. And that triage actually makes sure that the knowledge repository which you are supplementing on top of the knowledge which you are building through is effectively utilized. If this triage does not have good metrics across all these three pillars, that means it has not been effectively used and you have to really work onto it. And also, truly speaking, there is responsible AI, right? We all have, almost all organizations have major pillars around responsible AI. And it talks about many things, that there should be no bias. Even you can see in this picture, they have 6 different pillars, and we make sure that it is transparent in the answering. It should be explainable and all those things. But how do you measure it? These are the pillars which has been aligned to the responsible AI, and there had to be metrics around it. So suppose I say that the model should be transparent. And what do I mean by model to be transparent? That has to be defined by me. So suppose I am defining a SQL to text kind of model, then I say that the model has to be transparent. That means that the query which I am running in the backend, might be it should be available to the end user in order to utilize it and further utilize it, analyze it, because the end user would like to see what is the query I'm running at the backend. This is just an example. So for each of these responsible AI, right, these are very big terms which has been defined, and these are of course a guideline which has been provided to us, but we can define a metrics around it. Even if you say there should not be bias or there should be fairness, but how do you measure that fairness, or how do you measure that there is no bias, has to be effectively set. Like suppose I'm developing a banking model, right? And I might have preferred clients, or I might have customers. Suppose there are different type of customers, but there are some customers whose transactions are huge, right? Might be when I'm developing a model on top of it, my model is more biased toward the customers who have better transactions, huge transactions. So this is again just an example, but when I'm defining that there should be no bias or there should be fairness, I have to really define what I will try to measure it. And that measurement need not be a metrics very specific to LLM, but that metrics has to be defined, because you really want to implement responsible AI while you are implementing the LLM. And the final bit of it is also with the model enhancement. So you can see that if you do prompt engineering or fine tuning RAG or any of these or all of these, there are cost effect associated with it, and depending on how the cost is, you have to really keep on optimizing, and then there is a trade-off also. So for model enhancement and even to practically deploy it into the production, ultimately you want it to be productionalized. And from the scalability point of view also, there are multiple models which multiple metrics which we have. I hope this answers your
Yes, this
question.
this is fantastic. I wish we had more time to just, drill
Yeah.
down deeper into this. I was
Yeah.
just thinking like how you do the metrics for just when you said RAG that you're going to use RAG. I was just
Mhm.
thinking how what kind of metrics you use for even like a RAG system, which RAG system, and whether it's doc precision or page precision or how do you test that out? But you gave us a lot more. Thank you so much. Yeah, this is good. You can proceed. Thank you so much.
Okay, great. So, maybe I'll conclude with this architecture which we have, and this is a very high level architecture, and there are many slides in between, but respecting the time and the context which we have set through. See, this I picked it up from the LangChain site itself, and if you're trying to implement any of the LLM model, there will be multiple phases. And of course, depending on what kind of model which you are trying to put, right, whether you are just using prompting, or you're putting a RAG, or you're trying to put a fine tuning, architecture might differ. But this is a very generic architecture which I have picked up from the LangChain site, and what it says that you can have multiple sources. So you can, here it shows PDF, but you can have multiple sources. You can have documents, you can have databases, you can have anything. So you take these documents, and of course documents are text and it's too huge to process. Therefore you need to chunk it. So the second step of it is, the first step is of course ingestion. And if you take any of this platform, earlier it was a little difficult because you have to use different type of library. But if you are using any of this framework, actually ingestion through any of these APIs or any of these sources had been made very easily, because you have specific libraries which are dedicated for data ingestions. So you can very easily reutilize it. So once that data ingestion is the first part, second part is of course chunking the text. So you has huge amount of text and you want to break it into small pieces. Again, while we're chunking, right, there are different ways which different platform provide, and we have to be very specific what level of chunking we require. Whether chunk which we are dividing should be 100 tokens or it can be thousands token, or what is the chunk size which we are maintaining, how much overlap we are maintaining. There are different methods which has been defined, and also if you adapt to a different method, you will see different type of performance and it will affect your metrics. So you can always track back and see how you have really chunked through. That is step number two. The third one is creating the embedding, and we all understand internally, if we have to store this text, then the text is not what we are storing. We are creating embedding out of it and we are trying to store it, and therefore we create embedding. You can create embedding using any of the LLM model. And once you create the embedding, you actually store it into vector db. So in this picture it shows Pinecone, but we are using ChromaDB, we are using FAISS, and many more vector db are utilized. And the whole purpose of storing it into vector db is that later when you have a user, and in this case here your user is asking you a query which is again a prompt, then in that case you again the prompt is now converted into the embedding. So you have a prompt and you have a question embedding. This question embedding and the vector which you have stored, it actually goes through a semantic search, and it does the semantic search based on many of the similarity scores which we have available. But depending on the semantic search which has been available, it actually ranks your result and it will return you the ranked result out of the vector search it has done. This ranked result now become an input to your LLM, and in LLM will in turn frame your response back and it will return it back to the user. So this is at a very high level, the architecture of it. But as I told, you can have different version of architecture, and there are some key aspects which we define when we are defining the architecture. One is, when you are doing this kind of model, right, how scalable you can make. You can develop a very complex architecture. You may plan to develop a very complex architecture altogether in the first go, but what we keep in mind is any solution which you want to provide, right, it should actually work in production. So even a small part of it, you architect it and you put it into production, you start deriving an ROI, and then you keep that architecture as scalable so that you can keep building on it. So there is always a agile approach on how we implement it. If you have to implement several, like in the previous slides and all we saw, right, you have if you have RAG model, but on top of the RAG you might have multiple other models which are running in at the backend. You can have routers, you can have text to SQL, and so on. So these, you can have complex models all together, and you can plan to put it all together, but it will make architecture very monolithic. Rather, try to break it into chunks, make it agile, so that those agile pieces of architecture can actually go in production, and then you can keep on scaling it. And one important part of it is about language inference, and here I will end up my presentation is related to the optimization of the inference. And we do understand that when we are dealing with this large language model, right, these are actually the models which will not run on your CPU. So you need very enhanced machine. You either need GPUs, you need VRAMs in order to run through, and then there are multiple formulas which we have. I'm not going to that complexity. But then when you are utilizing such amount of resources, right, can we do something so that we can reduce that cost? And how will you reduce that cost? Quantization. There are multiple ways. One is, of course, quantization. Quantization is basically when you are trying to store each model parameter into lower precision. So what we do in this case is, suppose you have a vector generation, right, and you need in that each parameter has been represented in float 32 data type. Then actually you try to map all those representation into int 8, so it actually get mapped to the smaller precision of the data, and then you dequantize your result back when you really want the responses to thrown. So quantization is one way. Similarly, we have knowledge distillation, where you can say that you have a pre-trained model, huge pre-trained model, and using this pre-trained model you actually try to generate a distilled version of that same model, which will actually do a prediction for that. And the best example of this is when the BERT came into picture. It was a huge, like BERT came with the BERT base and BERT large, right? It was a huge model. And then soon after BERT came, we have multiple version of BERT. We have distilled BERT and many other smaller version of the BERT which can run more effectively. And the third part of it is about LLM pruning, where we do understand that actually LLM is nothing but a neural network inside, and where you can prune, you can remove the weights. So you have a bigger, larger LLM model, and you remove these weights. You can do it either symmetrically or asymmetrically, even if you don't do symmetrically, but you will actually end up getting a pruned LLM, and then this pruned LLM can be actually used for the prediction. So there are multiple ways by which you can optimize it, and of course this is not a mandatory field when you are designing your architecture, but from the cost monitoring perspective, and mainly in order to maintain the latency, this is very important that we plan our architecture in such a way that we plan the optimization of the usage of LLM along with our architecture. With that, I think I will come to the end of the session, and if you have any further questions, Yasha, I'd love to answer those.
Yeah, Suresh has a question here. Could you share insight on how you see all this evolving in the industry in the next 3 to 5 years?
Yeah, that's a great question actually. And truly speaking, I'm if even if you have little awareness, I have been spending a lot of my career in banking. But even if I go out of the banking sector, and of course I talked about so many use cases, I can keep on talking about use cases which we have in banking. But I feel that none of the domain is now untouched with the Gen AI or the AI touch. and you take healthcare, you take retail, you take any of the field, they all have their use cases. And sometimes it is very interesting to read through what they are really doing and listen to their top leaders. I had been working for Levi's Stores as a data scientist a few years back, and when I was given this position, I was very thoughtful that what kind of use cases a retail domain might be doing, and because I have always worked in banking, but then there are so many things which we are exploring through. And also the evolution of this LLM is very rapid with the kind of sensor machine IoT devices which we have. So it is not only the data which we had, but the exponential growth of the data also which we have, right? So now the data are also really growing exponentially. You can have in-house data, private data, you can also have public data, you have tap on the IoT devices, and you can merge all these platform together and then do fantastic analytics. Of course, the first step of it is first clean the data and get it into a platform where it is reusable. But that is another topic altogether. But to answer it, I think none of the domain has been untouched with the evolution which we have with GenAI.
Thank you so much. Yeah, it's it's a very good talk. You have so much knowledge in this domain, so I'm very appreciative of you coming in and giving us this opportunity to listen to you. So that's
Thank
it.
you.
Thank you so much. Yeah.
Yeah, thank you, Supriya. I think I've just missed one question from Sudha. That is regarding data drift, particularly model drift, and how do you find about the drift and how do you deal with it? At what stage of the LLM app life cycle do you deal with it?
A very good example, and I'll give you the best example when we had COVID. So before COVID, talking about Gen AI application is altogether a very different thing. But when I was working for Levi's Daughters, mainly we had application who were doing price and promo, right? Even if you have to predict the price and promo for multiple products of yours, and it was simple LLM model which were not might be Gen AI based or might be word based at that point of time. But the data drift happened, right? We had COVID, and suddenly from having all the business on to the stores, we landed up having no stores. So that was a huge drift. Other drift was everyone started purchasing online. And then the pattern of purchase also changed. So even if you say Levi's Tortoise, no one is now buying a jeans. The trend of buying has changed. So of course you can have data drift based on seasonality, based on the condition, based on the region in which you are operating through, and multiple other factors. One best thing to do, and in that case when we had COVID, actually we had multiple models. We used to make models where we used to train them before COVID, and we used to train it post COVID, and then we used to merge the result together, or might be we used to run two different model in many cases in order to do the prediction. But even if you have data drift, I think it can be handled in multiple ways. One is keeping the monitoring, first of all, how you monitor that data is drifting and what kind of data drift is there. That require itself a lot of knowledge onto the data, how much aware you are with your own data. That require a clear understanding of the domain and what data you are actually trying to host, and those are kind of prerequisite, I'll say, before you work on this model. And once you have the data drift, you will have a better control on getting it back on track. It might require multiple things, specifically if you say Gen AI, then it might be supplementing with the new augmented data, or it can be supplementing it with new methods. Might be you need to tweak the model. But what kind of treatment you will do in order to handle that data drift require a lot of pre-knowledge of your domain and your data which you are hosting there.
Yeah, so we have very good feedback that they have been putting on the chat here. I would like to read some of them. Ravi is telling practical examples, also blending theory with practices was excellent. And we have Sudha telling it's a fantastic talk. Thank you very much. And Great talk by Ravi and Suresh. Suresh has expressed his appreciation of a very good talk. And I have to say, the kind of knowledge you shared with us is something that no textbook can give. And you have been in the trenches and uh, soiled your hands and you have shared it with us. Thanks for sharing this valuable information. And I would like to invite you to the other WeeklyWed sessions that we have on Wednesdays. Do come to us and share your expertise here. So Weekly Wednesday happens every Wednesday at 9 a.m. Pacific time. And this is a wrap. We will meet next Weekly Wed.
Yeah, Yash, I'm sorry to interrupt. Can you please invite people to join the community, because I want to do an evaluation project of Agent AI, no-code AI tools to build Agent AI. Can you please tell people about that? I've just posted the community link in the chat also.
Yes,
want-
yes.
Yeah, I want to see if we can get not 20 people or too many people from here, but maybe in small groups of 3 or 4 people to evaluate some tools that I'm playing with, so that we can, apply it for various different scenarios, the way people are thinking from their industries and their roles.
Okay. So actually it was a teachable link. So we
Okay,
thought,
here is it is. It's I added a bit.ly/Sudha Agent AI goes to the teachable link. That's our community for WeeklyWed. You could actually show that, Yash, if you have a moment.
Sudha, actually I couldn't. Okay.
Yeah. Yeah, I just added the full link. We just made a thread, like a post in the community forum area. Usually we have one for each week where we share the deck from the speakers or continue discussion. But what we want to do is get together as, a small group of people and evaluate different LLM tools. And everybody's doing this in industry, everybody's doing in their jobs, but there are cutting edge new tools that's coming up in the agent AI world. And tools in agent AI world has a different meaning. I'm not talking about tools as tool, the tools to be used by the agent only, but these are no code AI products that some of them are good, some of them just, uh, claim that's no code, but might not be no code. So I'm looking at one called Promptly, and there's a site called Try Promptly, and it connects to a lot of different APIs. You can select various different LLMs, you can select various different tools, various different data sources, and then it's left to our imagination on what we build. So I want to see whether we can do something like that. We have done that in the past when we were learning machine learning many years back in early stages. We've done one with even labeling and tools for labeling. I would like to do that with agent AI tools, because it's a evolving new space. So if somebody is interested, then come add a comment, or show your interest in or say what industry or what use case you're thinking, or just say you want to be part of it. We will do a call and follow up. But again, all of us are working and have our busy lives and across time zones. So we'll try to find time. Thank you, Adam. Adam, you have to come. I will not be following up on the text here after this session is over. So you'll have to add a comment in the link I've given. That is the bit.ly/Sudha Agent AI. Sorry, it sounds such a presumptuous name. I didn't mean it, but I couldn't find any bit.ly that was left I could use. So it's bit.ly/Sudha Agent AI goes to our community. And I've added the expanded link also here in the chat. So if you want to come here and say you're interested, then we will find time. And I would like to get mix of people. That's what we typically do. Mix of people from different industries, different working on different roles within the the LLM building life cycle, different use cases so that we can brainstorm to build something interesting and then go play with the tool. That's kind of the idea. That's what I do eventually in my classes. But to build out the course, I play with a lot of these tools. I want to bring you guys to, work with me on a couple of them. It'll be like a fun exercise. It's not going to be, extensive, time consuming, but it's just to, play with some fun tools. And then you can go offline and go do your own thing and come back also. But we'll do like at least 1 or 2 calls. We'll coordinate. That's the idea. Yeah. So come to the community session and say you're interested, or, say what role you're coming with, or what use case you're thinking, or what industry you want to represent, or just say you're interested, and then we will find 4 or 5 of us max to kind of do this. And I'm looking at a tool called Promptly. Okay. Thank you, Yash.
Thank you, Sudha. I hope everybody has saved the teachable link, the bit.ly and the expanded version, and see you all in the community area. So Sudha, I just thought I will close the session. Anything else that I have to add? Okay. Okay, then. Thank you, Supriya. Thank you, everybody, for joining. Thank you, Supriya, for sharing your knowledge with us. And this is a YouTube recording. I'll share the link with you. And thank you. Catch you,
Thank you.
everybody,
Thank
the
you so
next
much.
weekly.
Thank you so much, Supriya. Bye. Thank you, Yash. Okay, bye.
Thank you, Sudha. Bye.